All right, so welcome back. I'm going to talk about another really easy introductory subject. So we're going to talk about matter a little bit. Since this is chemistry, it's not very good, so let me try. Hey, red shows up better. All right, so we're going to talk about matter. So matter is anything that's real, essentially anything that has mass and occupies space. That's what you've learned in the past, but really anything that is matter, right? Density is a common measurement of matter, right? Density is mass divided by volume. So grams per centimeters cubed, and a common reference is centimeter cubed is equal to a milliliter, right? So we use centimeters cubed for solids, and I'll use milliliters for liquids. If you're keeping a formula sheet, right, we had the percent error on a formula sheet. Keep your density in a formula sheet too, because you're going to use it. So I'll make sure I mention that we keep a formula sheet. The atom is the basic unit of matter. So everything that is made of atoms, right? And the atom is the basic unit that cannot be separated by physical or chemical means. So an element, so an atom, right? So atoms atoms that are similar are called elements. Right? What do we mean by similar is they don't have to be the same. Clean that up a little bit. So an atom, an element, are atoms that are similar. So they have similar physical and chemical properties. They don't have to be the same, but they have to be similar. Right? So an element can't be separated into simpler substance by physical or chemical means. Keep track of this. An element is considered a pure substance. There are two pure substances. An element is one. If you're taking notes, make sure you take notes of that. We have our periodic table of elements. There's slightly more than 100 elements listed. You may be up to 118, 120 now. It goes up all the time because we create elements. But of those, there's not as many naturally occurring. Periodic table organizes them, right? And they have 1 or 2 letter abbreviations. I think we're all familiar with all that stuff right now. So a compound, so we have elements, we have compounds. So a compound is a group of elements chemically combined. So chemically combined, this is another word for bonded. So these are bonded together, right? So I can even say bonded by electrons. So the electrons that surround elements and atoms hold things physically together, right? And that's a compound. So a couple things about compounds, right? They're formed during chemical reactions. They can be separated by chemical means. So they can be separated by chemical means, not physically. Since they're chemically combined, they can only be chemically separated, right? So if I have hydrogen and oxygen, I give it a little bit of energy, that's that little triangle there, and I can make water. Now if I want to take water and make hydrogen and oxygen, I can't do it by just simply cutting the water up, right? I have to put energy back into it, more energy, and I can separate it. So I can chemically separate it, but I can't physically, right? Symbols used to describe are the exact amounts. So compounds, we can say, I'm going to expand on this. Oops, I say it right down here, so I have to say it. Right? So compound, chemically combined, and here's an important thing, in fixed ratios. Right? So fixed ratios means that the numbers have to be the same. So if I look at this compound right here, these are subscripts. And these tell so in this sugar molecule, right, it has 6 carbons, it has 12 hydrogens and 6 oxygens. right? So that's the fixed ratio. As long as it has those correct subscripts or correct ratios, then it's the same substance, right? So for instance, water, if we take water, it has 2 hydrogens and 1 oxygen. If I take this, it's not the same substance, right? Because it has 2 oxygen, it makes it hydrogen peroxide. If I drink water, it's refreshing. If I drink hydrogen peroxide, well, if it's pure hydrogen peroxide, it's probably pretty toxic, right? If I drink this, right, this is hydroxide, right? That's a hydroxyl group. This is very toxic, right? It only has 1 hydrogen instead of 2, right? So the only one that's water is the one that's in the correct fixed ratio. So compounds, right? Compounds are considered a pure substance. Remember, you have 2 pure substances. You have elements and you have compounds, right? Cannot be separated by physical means. Right, so that's your other pure substance. So mixture is an aggregate. An aggregate simply means grouping. Right, grouping of substances, compounds, elements, mixtures, physically combine to make mixtures. So they're not bonded, they're just together, right? So if you were in school and you were all combined in your classroom, you'd be a mixture. You wouldn't be a compound because you're not actually bound together, right? You physically combined, you walked in. If you were physically combined, you could be physically separated, you could walk out, right? So a couple different classifications of mixtures you're probably already aware of. Mixtures could be homogeneous, right? So homogeneous has a couple things. Do not contain visibly different parts. So if you think about a cup of milk, it contains all these proteins and fat molecules and all this stuff just kind of floating around. Some bacteria in there, right? But it all looks like the same thing, right? That's called homogeneous, right? Also called a solution. So make sure you make aware of this because we use solutions a lot in chemistry. So think about homogeneous. Do not contain visibly different parts. Parts are equally distributed. So if I have a cup of milk, at the top of it I have the same amount of protein as I do at the bottom. All right, so it's equally distributed, and it has to be in a single phase. Phase means solid, liquid, or gas. Right, so it has to be a single phase. If we have a mixture of metals, it's called an alloy. Right, and that alloy, right, looks like a piece of metal. Right, it doesn't separate. It's in a single phase. It's solid. Right. The gas around you, the air, is a mixture, right? It's a solution of gas. Mixtures can be heterogeneous. Visibly different parts, unequally mixed, and it separates under normal conditions. So if you walked into my classroom, you'd be a heterogeneous mixture, because I could look around and I could tell the different parts of you from each other, and you could mix. It could be in different phases, right? So when you get that bowl of cereal in the morning, you put the cereal in there and you pour the milk, and the cereal's all floating on the milk, right? That's a heterogeneous mixture, right? Because the cereal's in a different phase as the milk, and it's not equally mixed. There's more on top than on bottom if it's floating, right? And I can separate it during physical means or by physical means, right? So here's some means of physical separation. Some of we're familiar with: filtration. Movement of a solid by size, right? I use a coffee filter because I don't want the granules to come through, right? So I get my solution, my homogeneous mixture of coffee. Coffee's good. Distillation. This is by boiling. So this, in distillation, I condense the vapor. So whatever comes out, right, as a gas, I'm going to condense and make it back into a liquid. So what I mean by condensing, this is what they do in the alcohol industry, because alcohol boils out of water faster than the water boils. So the alcohol vapor comes out, and they'll put it in the distillery, and it condenses that vapor and it turns back into a liquid. It's alcohol. Crystallization, right, is evaporation, right? right? So it's removal of a substance or the solid, right? So it's removal of solid after all of the water. So if I took salt and stirred it into water, right, I made a solution of salt water, I could simply just let it evaporate, and at the end I would have the salt left at the bottom, right? That's crystallization, salt becomes crystal. Chromatography. Right, we use chromatography in biotechnology quite a bit, right? Flowing along a stationary surface separated by mass, but really I could separate by mass, charge, polarity, or shape. So chromatography is used a lot in biotechnology. It's probably used the most of all these different methods. Right? And centrifugation, use this in chromatography or biotechnology a lot. Spinning difference, right? Separates by mass or density. Right, so if I was going to try to get the DNA out of your cell, right, I'd break your cell apart, and I'd spin it really fast, and all the hard parts of the cell would come to back, and the DNA would be floating in the, they call it supernate, or the liquid on top. So we use that in biotechnology a lot as well. All right. Chemical reactions. So we talked about physical. Let's talk about chemical reactions. All right, so chemical reactions occur when new substances are converted into when substances are converted into new substances with new physical and chemical properties. Okay, so that's the thing. It has to have new physical and chemical properties. So this occurs by the rearrangement of bond, or what we call electrons, right? Electrons make bonds. So if you consider this photosynthesis reaction, right? I've got water and carbon dioxide. It makes sugar and oxygen, right? So the sugar that I make has different properties than the water and carbon dioxide. Now, if I took sugar, I could not separate it physically. I could only separate it chemically, because this is a compound, right? All right. So the check for this is, right, the change is permanent. Right? If the reaction cannot be reversed physically, right, get the original reactants, then a chemical change is taking place. Right, so all chemical reactions must follow the laws of conservation. And you've heard these all since elementary school. Conservation of matter. Matter can't be created or destroyed, only transferred. Right, so matter of reactants is equal to matter of products. Conservation of mass. Right, mass can't be created or destroyed, only transferred. So the mass of the reactants is equal to the mass of the products. Then energy. Right, energy has to be conserved as well. Right. All right. So evidence of chemical reactions. I can have a physical change. It could be the color, right, texture, texture. So if I took sodium plus chlorine gas, I make salt, right? So sodium is silver and shiny, and chlorine is a yellowish gas, right? Sodium is very reactive with water, right? It causes electrons to spark. Chlorine gas is poisonous. It's toxic to living things, right? But I make salt with it. And salt's good. I put it on my French fries last night, right? So then salt's a white powder, right? So the physical appearance, the color is different, the texture is different, the luster, how shiny it's different, right? Transfer of energy, right? So when I do this, this releases energy, right? When I combine these, there's a spark, right? A flash of light, and then I make it. So it's exothermic, means releasing energy, and endothermic means absorbing energy. We'll talk about those next semester in great detail. So transfer of energy. The production of gas, right? Or effervescence, or the formation of a solid or a precipitate. Right? It could occur with a pH change. So those are all evidence of chemical reactions. Right? And that would be it. Okay? Talk to you soon.